Hi, thank you for joining us today. Today, we'll be telling you about what's new in network security on Google Cloud. My name is Emil Kiner. I'm a product manager on the cloud networking team, and I am joined by my colleague, Tracy Jiang, also a product manager on the team. First, we're going to start by giving you a brief overview of network security on Google Cloud. From there, I'll dive into Cloud Armor and share all the latest and greatest developments in the product. Next, Tracy will take over and talk about all of the new things with Cloud Firewall, and also share about our new product offering around packet mirroring. Security follows a shared responsibility model on Google Cloud. We work to secure our network and infrastructure and provide customers the tools necessary to do so as well in their own projects. We enable and encourage customers to follow a defense in depth approach and deploy security controls at various levels of their stack and infrastructure to enforce access controls and ensure data and mission critical workloads remain private and secure. On Google Cloud, we have several key network security controls. Starting from the outside in, we have Cloud Armor, the identity-aware proxy, and the global load balancers as our layer 7 controls at the edge of the network. Cloud Armor, in conjunction with the global LBs, protect applications from DDoS attacks. The IAP is part of our Beyond Corp line of products to allow access to internal applications and workloads without needing a VPN. Firewalls, in red, apply at the VPC level and can be used to customize access for north-south traffic as well as east-west traffic into, out of, or through a VPC. Firewalls are used to define VPC boundaries but can be as granular as per host. VPC service controls, in blue, can be used to control access to and from GCP managed API services such as BigQuery or Google Cloud Storage to or from the internet, into or out of your VPCs or on-premise resources. In yellow, we have our latest offering, packet mirroring, that allows you to deploy a tap and mirror packets at the VM or container cluster boundary to a configurable collector destination. Finally, we also support sending outbound traffic through CloudNet to enhance privacy and security, as well as various interconnect and VPN configuration options. With Cloud Armor, customers are able to protect their applications from DDoS attacks, filter incoming requests by geography or most layer 7 parameters like request headers or cookies. Moreover, as a web application firewall, Cloud Armor contains pre-configured rules to prevent and mitigate the most common attacks and vulnerability exploit attempts. Users have access to real-time telemetry in the form of cloud logs containing Cloud Armor's decisions on a per request basis, as well as a real-time monitoring dashboard that gives granular views of allowed, denied, and previewed traffic. With Google Cloud Armor, customers' applications and websites are protected with an unrivaled level of DDoS protection, as well as a web application firewall able to satisfy internal security policies as well as external regulatory regimes. The DDoS protection cloud customers receive is the same that has been developed over the past 20 years to help protect and ensure the availability of Google's own services. In conjunction with the global load balancing infrastructure, we are able to absorb and mitigate layer 3 or layer 4 network or volumetric DDoS attacks with no impact on customer workloads. This mitigation happens automatically far upstream from customer infrastructure across all types of global load balancers, including the HTTPS load balancer, SSL proxy, and TCP proxy. Users can then configure Cloud Armor security policies to enforce layer 7 filtering policies and WAF rules on a per backend service basis. Cloud Armor security policies can be used to enforce IP or geo-based access controls, mitigate OWASP top 10 risks, and otherwise filter traffic upstream of an application based on layer 7 attributes. Today, we are proud to share that a rich set of WAF capabilities for Cloud Armor is generally available. Pre-configured WAF rules can help mitigate the OWASP top 10 risks. We have ported over the mod security core rule set, introducing rules to detect and block SQL injection as well as cross-site scripting attacks. Additionally, rules for local file inclusion, remote file inclusion, and remote code execution are available as beta. The rest of the core rule set is targeted for release over the course of this year. With geo-based rules, customers can enforce access controls based on the source geography of each request. IP to geo mappings are sourced from Google's geo team, so you can be sure of its accuracy. We've also launched an extensible rules language that allows users to configure custom Layer 7 filtering policies across request headers, request parameters, or cookies. Finally, CloudArmor is now integrated with the Cloud Security Command Center, with CloudArmor findings being sent to the CSCC dashboard to alert defenders of potential attacks against protected applications or websites. We have recently greatly increased the flexibility of a CloudArmor deployment to protect an expanded set of customer infrastructure on GCP, as well as in hybrid use cases located on-prem or in other cloud providers. CloudArmor now supports protecting Cloud CDN origin servers by enforcing CloudArmor security policies on dynamic requests, as well as cache misses destined for the CDN origin server. Customer applications are often complex, serving both cacheable static content as well as dynamic requests from the same services. With CloudArmor able to inspect and filter requests destined to CDN origin servers, users can now mitigate computationally expensive cache busting attacks, as well as help protect dynamic portions of websites and applications from the OWASP Top 10 risks. Enterprises often need to enforce a consistent set of security controls to their applications no matter where they are deployed, whether they are migrating to GCP or running in permanently hybrid configurations. We've recently launched support for Internet Network Endpoint Groups that allow customers to leverage all of Google's edge infrastructure, including our global load balancers, Cloud CDN, and CloudArmor to protect their website or applications no matter where they are hosted. Now Google can help protect your applications, whether from DDoS attacks or other common web attacks, without customers having to deploy their infrastructure on GCP. Finally, GKE ingress support for CloudArmor has reached general availability. GKE users can help protect their containerized workloads by placing them behind Google's global load balancers and configuring CloudArmor security policies for Layer 7 filtering and WAF use cases. With that, I'd like to hand it off to Tracy to discuss cloud firewalls.
Thank you, Emil. In the next section, we're going to be going through the cloud firewalls. First, we'll give you a quick introduction about the VPC firewall rules. Then we're going to be talking about two new modules that we recently brought to market to strengthen our firewall offerings. Google Cloud Firewall has a different architecture than the traditional firewalls. In a sense, it does not have a physical box that you need to configure and pipe your traffic through for filtering. Instead, it is offered as a virtual firewall service that is fully integrated into our Google SDN fabric. The policy enforcement happens on the host for each individual VM instances. Compared with the traditional model, this type of architecture will give you higher scalability and has no choke point. It is a fully scalable and stateful firewall that inspects both ingress and egress traffic. Users can also make use of the network tag service account to define the fine granular firewall rules and implement their micro-segmentation strategies. As we know, the VPC firewall operates at the VPC level. It allows users to define an independent set of firewall rules for each individual VPC. This gives you, the project owners, a lot of independence and flexibility in controlling your firewall rule set and operate in such a dynamic cloud environment. However, it does present some challenges for corporate security teams in large enterprises. This type of organization typically has hundreds, sometimes even thousands of projects and networks in their same organization. Oftentimes, they want to implement some common rule across all the networks and the projects. Without a central control, it's typically very difficult to do so. Also, the project owner oftentimes do not have as in-depth of security knowledge as their security team does. Therefore, they could make some mistakes and misconfigure their firewall rules, and then expose their workload at risk. How to maintain a dynamic and safe cloud environment and strike a delicate balance between control and delegation has been a constant battle for those central security teams. Hierarchical firewall policies are introduced precisely to address this type of pain points. With hierarchical firewall policies, users can define and attach firewall policies at a higher level of the hierarchy, specifically organization and folder nodes, where the centralized control can be defined and enforced. Firewall policies is different from traditional firewall rules. It is a container that can contain multiple firewall rules. In there, it can be defined once and then later attached to different nodes in the hierarchy. Also, when you try to modify the rule set within a central policy, you can actually execute it in a batch mode. When firewall policies are attached to different levels of the node in the resource hierarchy, they follow a very strict enforcement sequence from top to the bottom. All traffic must pass the org level security rules before they be evaluated at the folder level and then eventually at the VPC level. This type of model made it impossible for project owners to bypass or overwrite security policies that are set by the central team. It also makes sure that any new project and new networks added to the organization can be protected by those central policies from day one. Defining rules at the org and folder level doesn't mean that all those rules must apply to all instances in the same way. User can actually use target service account to designate certain instances for selected rules. For example, a user could define a firewall rule sitting at the org level that forbid all the egress traffic and only allow the egress traffic for a selected set of proxy servers that with certain service account associated with it. Another module that we recently brought to the public beta is called Firewall Insights. This module is introduced to help our customer manage complex firewall rule set in a large VPC environment. Many enterprise customers face challenges in maintaining a clean and robust firewall rule set over time and face many challenges such as massive volumes. A VPC can have hundreds or even thousands of rules associated with it. Overgranting is another issue, but lack of visibility into the rule usage data is typically very difficult to find them out and eliminate those type of risks. Human error is another factor that could introduce misconfigured firewall rules. And outdated rules were the ones that left over by the previous project but never gets cleaned up. With Firewall Insights, we introduce a set of capabilities that hopefully will help our customer better manage those challenges. First, we introduce a set of metrics for firewall usage, such as the hit count and last hit time. Using these metrics, users can easily find those allow rules that are not used and clean them up in order to tighten the security boundary. During troubleshooting time, users also can make use of those rules to know precisely which rules are being hit when certain traffic passes through. They can also detect abnormal traffic pattern by observing sudden jump in their hit trend. All those metrics are exported to Stackdriver, where users could use them to create custom dashboard, define user-defined alerts in order to catch conditions they are interested in. Firewall Insights also brings a module that automatically scans the entire project for all the firewall rules and detects shadow relationships. A shadow rule is a rule that is overshadowed by one or more rules sitting at a higher priority. Without machine's help, it's typically very difficult to find it out manually. With Firewall Rule Insights, we report centrally for all the shadowing relationship in a project, and we refresh that periodically so that user could simply go through the report, examine each shadowing relationships, and eliminate them as needed. Next, we're going to talk about the new module that we recently brought to market called packet mirroring. So what is packet mirroring and why do you need it? As we know that to build a robust threat detection program, we need the combination of the network threat detection system combined with EDR and SIEM to give us the critical visibility that enables quick threat investigation and response and minimize the damage during an attack. Network data is often considered a ground truth. It provides a complete visibility of the network activities. It's usually difficult to evade and cannot be easily turned off. During an attack, when an infected host is trying to reach another host, the moment a packet leaves the host, it will leave the trace in your network data, which will be captured. Therefore, it's often considered a very reliable data source for threat investigation. Many of our enterprise customers are already taking advantage of this set of data, use set of tools to collect and analyze those data for their security purposes. When moving to the public cloud, they sometimes cannot get the same level of visibility into the network traffic. However, when they are moving more and more workload into the cloud, their networks start to become very complex. Therefore, they demand the same level of visibility for the network traffic for performance monitoring and security control purposes. GCP packet mirroring is introduced precisely to address this type of need. It helps users increase their confidence in their cloud migration and ensure a smooth transition and give them the ability to implement advanced and proactive security controls. GCP packet mirroring is now generally available in all regions for all VM instance types. It can help capture traffic from all different directions, traffic between VM to VM, between VM to Internet, also between VM to Google services. When combined with intrusion detection systems, it can help users easily detect abnormal traffic patterns and capture the emergent risk. It can also help them satisfy the compliance requirement and also used for application performance monitoring and troubleshooting purposes. Now let's take a look how the packet mirroring works under the hood. Packet mirroring can be enabled for both GCE VM instances as well as GKE clusters. It happens at the instance level. So whenever the packet mirroring is enabled, it captures all the traffic, both ingress and egress, including the header and the payload. To configure a packet mirroring, you need both front-end and back-end policies. The front-end policy will define which instance will be enabled for packet mirroring. You can specify specific individual instance to be activated. You can also specify a group of instances by specifying the subnet or using network tags. The backend policy specifies where the collector endpoint is. A collector endpoint is an internal load balancer that sits in front of a group of collector VMs. The collector VMs usually are running a set of partner solutions such as the Palo Alto's IDS systems. When the policy is defined, the packet mirroring traffic will be piped through the internal load balancer into those collector VMs, where the different systems will consume those traffic to perform different type of functionalities. We recommend that you use instance template and managed instance group to manage these collector VMs. It will give you auto-scaling and auto-healing capability and help you meet traffic demand and availability requirements. Packet mirroring can be configured via API and gcloud command. It can also be triggered and enabled through the cloud functions. While packet mirroring provides critical data that enables a set of critical use cases, it won't be the complete solution without our ecosystem partners' support. Therefore, we have built an ecosystem with vendors coming from network security and network monitoring domains, so that our customer could make use of the tool that they are familiar with to consume those packet mirroring traffic and build it a solution to satisfy their needs. To learn more about the network security functionality that we just went over in this session, here are a list of resources including blogs, documentation, live demo, and some other next sessions that you want to refer to. Thank you very much for joining the session today. We hope you enjoy the rest of the show.